Students, in this class we will be doing class 9 matriculation syllabus or Samacheer syllabus. Already one exercise I have completed. Now before doing the second exercise, few things we have to know. After knowing these only you can able to do those sums in that exercise. So that is types of set. Okay, so we know what is a set. Set is a collection of well-defined object. Okay, so here few types of set we will see. So types of set. Empty set or null set. Empty set means that there is no element in the set. For example, if you take odd numbers between 4 and 5. If you take odd numbers between 4 and 5, there is no odd number between 4 and 5. So that is called empty set or null set. Okay, so empty set or null set. It is defined by, it is written as like this. Okay, you will put a 0 and cancel it. That is null set. Okay, then next one is singleton set. That is, there will be only one single element in that set. Here for null set, there is no element in the set. That is empty set or null set. And this one is singleton set. That is, there will be only single element in the set. For example, even prime number. There is only one even prime number. What is that? 2. 2 is the even prime number. All other numbers are odd numbers. Only 2 is the even prime number. For prime number, only 2 is the even number. So that is singleton set. That is, there should be only one element in the set. That is singleton set. Then next one is finite set. Finite means countable number of elements in a set. Okay, if you take for example odd numbers between 1 to 20, that is countable. What are all the odd numbers? Will be between 1 and 20, 3, 5, 7, 9, 11, 13, 17, 19. So these are all odd numbers. So these are all odd numbers between 1 to 20. So you can able to count the number of odd numbers in between these two numbers. So if it is a countable number of, if you have countable number of elements inside the set, that is called finite set. So finite set is nothing but countable number of elements in the set. And then infinite set. So this is the opposite for that. Infinite set is, we cannot count the number of elements in the set. For example, stars in the sky. Okay, then a handful of sand. All these are examples of infinite set. Okay, then odd numbers. That is simply, if you are telling odd numbers, n number of odd numbers are there. So it is not countable. So this is infinite set. That is, next one is equivalent sets. Equivalent sets means when you take any two finite sets. Okay, when you take any two finite sets, that is A is 1, 2, 3, 4. So how many elements you have in this? You have 4 elements you have in this. Then if you take set B, in this A, B, C, D. These are all the 4 elements in the set. So these 4 elements, here you have 4 elements in set A. Here you have 4 elements in set A. So if you have same number of elements, in these two sets, if you have same number of elements in the set, they are called equivalent sets. This one is comparison of two finite sets. So in set A and set B, or if you take any two sets, if you have same number of elements, not same elements, same number of elements are there. 1, 2, 3, 4. Here you have 4 elements. Here in this A, B, C, D, 4 elements are there. So if you have same number of elements, that is called equivalent sets. Same way, if you take equal sets. Equal sets means it is opposite to this. That is, when you take any two finite sets, for example 1, 2, 3, 4, and the other set is 2, 3, 1, 4. Since here in this order is only changed, but same elements are there. 1 is there here, here also 1. 2 is there, 2. 3 is there, 3. 4 is there, 4. So same elements. So number of elements also should be same, and elements also should be same. So here 4 elements, 4 elements are there. in both these sets and then same elements. So equal, so that is called equal set. Same number and same element should be there. Okay, it should be a repetition of the other previous one. So that is called equal sets. Okay, then universal set. So when you take many sets, that is, for example, if I am writing numbers from 1 to 10, 1, 2, 3 up to 10. So 1, 2, 3, 4, 5 up to 10. Then from this I am writing many sets. Here 1, 2, 3, 4 I wrote. Then 5, 6, 7, 8 I wrote. Okay. From this set only I am writing the remaining set. So this is called universal set. From a particular group I am segregating the different groups. Okay. From here, from this only I am taking the remaining sets. So that set is called the universal set. So that set is called universal set. Then subset. Okay. So next one is subset. Subset means, for example, if you take 4, 8, 12, 16. So these are the 4 elements in this set. Okay. So B is equal to 4 and 8. These are the 2 elements we have in this. So we will say that B is the subset of A. You should have elements, not all the elements. Few elements you should have in the other set. So B is called the subset of A. So B is called the subset of A. There should be few elements in the other set. So you will say that as B is the subset of A. We can write it like this. B is the subset of A. So that is the meaning for subset. Then next one is proper set. Proper set also somewhat similar to this subset only. Okay, you should have few elements, not the same elements. That is, if you have 4, 8, 12, 16, that 4, 8, 12, 16, if it is not there, then it is not a proper set. 4, 8, 12, 16 if you have. That is, if you have 4 elements you have in that set, the proper set is 1, you can say it as a proper set. 1 alone. 2 alone you can say it as a proper set. Like that, a part of that from a given set, a part of element if you take, that is called the proper set. You will say that as the proper set. Okay. Then disjoint sets. So disjoint sets means if you take A as 4, 8, 12, 16. Okay. Then next set, if you are taking it as 5, 10, 15, 20. If you take the next set as 5, 10, 15, 20. There is no connectivity between this A and B. All the elements are entirely different. They are called disjoint sets. Okay. There is no joint. There is no connectivity between two sets. So that is called disjoint sets. Then next one is power set. Next one is power set. So power set means set of all subsets of any particular set. All those sets are together called power set. For example, if you take A is equal to 2 and 4. These are the 2 elements in that. We are asked to find the power set of this. That is, subset of all these sets are called the power set. So what are all, for all the set, null set is a subset. Okay. So what are all that, we will write it inside the bracket. So first one is null set. For all the set, null set is the subset. Okay. So first one is null set. Then 2, then 4, then 2, 4. So if you write all these things inside a set bracket, so you will get 4 subsets for this. So this is called the power set of A. So for finding the power set of A, this property is very important. For finding the power set of A, that is P of A, we will say. Since it is given as set A, we are writing it as power set of A. So the general form we will say it as 2 power n. This n is the number of elements in that particular set A. Here since we are defining it by A, number of elements in set A. Shall we check this? So this is 2. How many elements we have in set A? 1, 2. 2 elements we have in set A. So 2 2s are 4. So how many elements you should have in the power set? 4 elements you should have. 1, 2, 3, 4. So 2 power n is number of elements, that is 2 power n, number of elements in P of A. You will get 4 elements in it. So power set of A means set of all subsets of one particular set. Okay, now we will see examples, exercise sums we will see. Next we will do exercise 1.2. Find the cardinal number of the following sets. So cardinal number means number of elements in that set. That is called the cardinal number we will see of the following sets. So M is equal to P, Q, R, S, T and U. So how will you write the cardinal numbers? Number of elements in the set. That is called the cardinal number we will see. So M is equal to P, Q, R, S, T. So cardinal number for this is, that is number of elements in the set M. Number of elements in the set M. This is called the cardinal number. So how many elements you have? 1, 2, 3, 4, 5, 6. So n of M is equal to 6. That's all. Now next one is P is equal to X such that X is equal to 3n plus 2. Some condition is given for this. N belongs to W. W is whole number and X less than 15. So this is the condition given. From this condition we have to find the elements of the set. Then we have to find the cardinal number of the set. Okay. So first one is X is equal to 3n plus 2. So X should be, first one is this n belongs to whole numbers. What are whole numbers? Whole number starts from 0. 0, 1, 2, 3. Okay. This is the condition for this n. And whatever values you got for this X should be less than 15. Till that you have to continue the sum. That's all. So this one is equal to 3 into, first we will start with 0. Since it is given as whole numbers, 3 into 0 plus 2. So this one will be 2. So this is the first element of the set. Then next one, here we will take n is equal to 0. Then next one is n is equal to 1. So x is equal to 3n plus 2. This is equal to 3 into 1 plus 2. So 3 plus 2 is 5. This is the second element. Then n is equal to 2. So x is equal to 3 into 2, 3n plus 2. This is equal to 3 2s are 6. 6 plus 2, 8. Then n is equal to 3. So till what we have to continue? Till we are getting x value as less than 15, we have to continue this. So x is equal to 3 into 3 plus 2. So 3 3s are 9. 9 plus 2, 11. This is the next element. Then n is equal to 4. So x is equal to 3 into 4 plus 2. So 3 4s are 12. 12 plus 2 is 14. 12 plus 2 is 14. 3 4s are 12. 12 plus 2, 14. So obviously when you find n is equal to 5, that also I will find. But if you find n is equal to 5, it will exceed 15. So we should not include that number. So x is equal to 3 into 5. So 3 5s are 15, already you are getting. Plus 2 is 17. Okay, so we should not include this 17. So what are all the elements in that set? P is equal to 2, 5, 8, 11, 14. 2, 5, 8, 11, 14. So how many elements you have in this? That is number of elements in the set P is equal to 1, 2, 3, 4, 5. 5 elements is there. So cardinal number of the set P is 5. So with this I have completed few sums in exercise 1.2. Remaining sums I will do it in the next class. So whatever doubts you have, you post me in the message box. Okay, thank you.